In this video, we are going to discuss about the how to form the Tyson matrix in the graph theory, or we also call it as a loop matrix, which is represented by the BE matrix VE. Now, current in each loop of a graph is called the loop current, or we also call it as a link current. The current through each branch or each tweak is called the branch current. Now, these are some of the terminologies that we are going to use in the Tyson matrix: the current, the loop current, or the link current, the branch current, and this Tyson matrix will give the relationship between the link current and the branch current. The link current, which is also called it as a loop current. So this Tyson matrix will give you the relationship between the loop current and the branch current. Trisets are closed paths formed by adding each link to a tree. Now, in the graph theory, you will have the directed graph or undirected graph. If it's undirected graph, you have to make it the directed graph. You have to give some directions, and then you have to create one tree. Remember that we can have multiple trees for a given graph. You have to select one tree, and then in each tree you have to add a link. Okay, only one link and form a closed path, and then we have to apply the Kirchhoff's voltage law to form the Tyson matrix. Anyway, we'll look into it how to form that one. The formation of Tyson matrix: first one is arbitrarily a tree is selected in a graph. Okay, you are selecting any kind of tree. The nodes and branches of the graph are given the names and direction of arrow in each branch is assumed. See now without this direction and the name of the nodes and the branch, we cannot go ahead in the formation of the Tyson matrix. We have to give the name and branch, we have to give node and branch names, and then we also have to give the arrow of the direction, which is same as we're giving the we are using the directed graph. Then form our fundamental loops with each link in a graph for the entire tree, and then in the tree we have to add the link and then form a loop. Okay, loop current in each tie set is assumed again. See now, loop current, the direction of the loop current is again assumed. The matrix is formed. And if that again, now how to enter the elements for that the Tyson matrix? If the direction of the loop current and branch current are same, we assign plus. So remember here, if the loop current, we also call it as a link current, and the branch current are same, we give +1. Otherwise negative, which means if the current direction of the loop current and the branch current are in opposite, we give -1. And 0 is entered if loop current does not flow through that branch. Okay, remember that if there's no relationship between the loop current and the branch current, we give 0. Plus is given for those the current direction, the loop current and the branch current are in same direction. Negative is given when loop current and branch current are in opposite direction. So we have three elements: +1, -1, and 0. 0 for the no relationship between branch and the loop. Okay, now let's assume this one. This is the example that we're going to solve. So using branch 5, 6, 7, and 8. 5, 6, 7, and 8, draw a tree and form Tyson matrix for the given graph. So you have to form the tree 5, 6, 7, and using the branch 5, 6, 7, and 8. So in this, it's a directed graph, nodes, the name of the nodes, and the all the branch names are given. For this one, okay, solution. Okay, now this is the tree that we are forming 5, 6, and 7, and then now in so we have to add the link. Now if you're adding the link here, then you will have again fundamental loop here. If you're adding link here, you will have fundamental loop here. If you're adding link here, you will have fundamental loop here. If you're again adding link here, you will have fundamental loop here. 8 links in the tree and the loop current. So this is how our net that the net graph looks like. So these are the tree, right? 5, 6, 7, and 8. Now we are just taking part by part. For this, we are adding link number 1. Now this is the link, right? The link means which is not used in the formation of the tree. The branch which is not used in the formation of the tree. So we are using 5, 6, 7, and 8 to form a tree, and then we have link 1, 2, 3, and 4. So we have 1, 2, 3, and 4 are called link, right? So if we add the link, we are forming the fundamental loop, and then we are giving the loop current as I-1. And then here also we are adding link 2, and then we are forming current I-3, I-4, and I-5. Okay, now branch and link current are denoted as I1, I2, and I3, and loop current by I1 dash. So these I1 dash are the loop current, and for the branch current, we're simply going to denote it with the, for this one, I1, here we have I2, I3, I4, I5, I6, I7, I8. And then, okay, to form the now triset matrix. So in the row, we have a loop current, I1 dash, I2 dash, I3 dash, and I4. And in the column, we have branch and the link current. Now, if you look into here, okay, I will draw the another matrix for this one. Okay, I have prepared another what's it, the triset matrix here. Now, for this one, okay, I'll make it big. In order to enter the elements here, for this one, okay, let's take with the blue pen. Now, if you consider into the fundamental loop 1, here I1 dash, now loop current, the rows are loop current, and then the columns are represented by the branch current. So in this fundamental loop here, okay, this is your link 1, link 2, link 3, link 4. Okay, we have link 1. Now in this link 1 here, we have loop current I1 dash is in same direction with this one. So we can give +1 here. Okay, let's write +1 for this one. And then similarly, and then its relationship, this loop 1 relationship with link or branch 2 is, there's no relation, so we can enter 0. And then with the branch 3 also is 0, 4 also 0. And then we have relationship with 5, branch 5, so it is -1, right? They are in opposite direction. And then with 6, they are in same direction, so you can add +1. And then with 7 is 0, 8 is again 0. Now we are done with the fundamental loop 1 and its relationship with the branch and the link. So similarly, we can do it for other 3 loops. Okay, I have entered all the values here. So okay, let's again discuss, relook into this one here. So in this link 1 here, loop 1, current is given by I1 dash. So its relationship with the branch 1, this is the branch 1, or we also call it a link. Our main tweak are this one, 5, 6, 7, and 8. 1, 2, 3, and 4 are the added links. So we have added the links in order to form the loop, fundamental loop. So in this fundamental loop 1, we are finding the relationship. So this link 1 and this loop 1 current are in same direction. So we are giving +1. This link 2, link 3, and link 4 are not related with this loop current. So we have entered 0. And then for the branch 5, we have this loop current flowing upward, branch current flowing downward, they are in opposite direction. So we gave -1. And then for the 6, the branch 6, they are in same direction. See, I1 dash is in downward direction. Branch current of that branch 6 is also downward direction. So we gave +1. And then for the 7 and 8 is not related with this. So we gave 0. Similarly for I2, I3, and I4, you can have a look. And if you cross check this one with the your uploaded PPT, you'll find different metrics, because in the PPT I have taken this one as loop 1, then loop 2, loop 3, and loop 4. So the only difference is about the current, the name of the loop current assumption. In this loop, I have assumed it as a I1 dash, but in our case, I've assumed here in this loop as I1. So that's the only difference. Now with this tri-state matrix, we can find the relationship. So this, okay, where's the cursor? So you can find the relationship here. Your branch current I1 is equal to, so I1, this I1 is equal to link current I1 dash, okay, I don't know whether it will be visible or not. Okay, I1 dash, okay, your this branch current will be equal to +1 times this I1 dash, and then similarly your I2 will be equal to I of 2 dash, and then here again your I3 will be equal to I3 will be equal to your I dash of 3, and then similarly you can also find for all other okay. So I've written all the relationship here. Sorry, I think it's not readable, but I will explain here. Listen carefully. Now from this matrix, you can find out that your, see here, and this branch current I1, and the loop current I1, this one is given by I1 is equal to I1 dash. Similarly I2 is equal to again I2 dash. Here I2 is equal to this one I2 dash. I3 is equal to I3 dash. I4 is equal to I4 dash. And then for I5, it is the sum of minus I1 dash plus I4 dash. For the I6 is equal to sum of plus I1 dash minus I2 dash. And then similarly for I7 and I8, you can have a look. I've written here. And then in other words, we can also write the relationship like this. I of 1 dash is equal to I1, the branch current I1 minus I5 plus I6. So this relation and this relation are similar. Here we're making the loop current as a subject. Here we're making branch current as a subject. So that's it. And I hope you have understood how to form the tri-state matrix, and then from the tri-state matrix, how to derive the relationship. So in the next class, we're going to see the application, the relationship of this tri-state matrix with the Kirchhoff's voltage law.